Hello, everyone. Welcome to this lecture, another episode of Systems Development and Frameworks. Today we have two lightning talks. I'm very excited to hear something about continuous integration, continuous delivery by Ilona, and later on we will hear something by Jonas, and I think he's going to talk about Kubernetes, if I remember it correctly. Well, I think one of you wanted to give the talk in German. Stage is yours. Feel free. I'm excited to listen to your talk. And I'm also going to check the time. Stage is yours.
So, my topic is integration.
Kannst du mal ein bisschen lauter machen?
My topic is continuous integration, continuous delivery, and its role in software engineering. And therefore, I will show you a few examples of tools. Wait. Sorry. Why is it not working?
You need the presenter?
Yeah. Oh, yeah, sorry.
Oh,
yeah,
okay. Yeah, you have it.
Yeah. I want to show you my agenda, which first of all, I'll talk about the principles of CI and CD, going over to common CI tools and drawing out a conclusion afterwards. First of all, continuous integration is quite handy to integrate work of development teams on a daily or hourly basis, and the tools therefore are help to automate and build the test cycles. Successful CI therefore drops errors as they are instantly detected, and similarly, continuous delivery covers packaging and deployment, as well as orchestration, for example, with Kubernetes, so that the software is released to the different branches like development, staging, and production. And the software can also be measurable and adjustable, of course, preferably at low cost and high automation. Wrapping it up, CI and CD directly facilitates agile development, as both cycles complement each other and empathize automation. The aim is that the software reaches the production more frequently and the users can have the opportunity to experience it and review it instantly. A few common CI tools are, for example, Travis CI, which has an easy and quick setup. It has an automatic deployment and is cloud-based, so you can test different environment and OS operating systems. It offers integration for GitHub and is usually handy for small and open source projects, so you can use up to 100 builds. Commercial projects on the other side are rather pricey. Then on the other side you have Jenkins, which is fully customizable but has an extensive setup. It supports scaling and distribution of the software and is server-based, therefore requires Java runtime environment. But you can actually monitor deployment cycles and easily access different plugins. It is free and open source and therefore quite useful for large or complex enterprise projects. Other tools, for example, include GitHub Actions, which is built by the community. And I don't know if you've seen it already. GitHub Actions also includes sharing over the marketplace, Docker images, and repos. It's useful for projects that rely on GitHub a lot. It's a little slower than other tools and doesn't yet support bigger, heavy workflows, but is under heavy development and quite interesting to look into for in the future. Circle CI is similar to GitHub Actions as it has an easy setup and allows fast and parallel builds. It has a GitHub Docker support as well, but server-based and is rather handy for large and complex enterprise projects. Depending on the amount of container and the parallelization, it can become rather pricey, especially in commercial use. So wrapping it up, it's important to note that CI and CD is an important practice in modern software engineering, and both cycles equally use the automation of everything. And when choosing the right CI tool for your project, it's important to keep in mind what setup trade-off you have, what support, flexibility, and scalability you need for the project. So in the end, the choice of tools is entirely up to the team's projects and needs. If you'd like to look into it further, here are some sources and links. You can check it out. Thank you very much.
Nice. Thank you very much. It took 4 minutes. So yes, it was very quick. And now it's time for questions. First of all, applause. Also some virtual applause, please, in the chat. Thank you very much. Clap, clap. Yes. And now it's time for questions. Knocking on the table.
Go back to the slides with the...
Yeah, I actually have one exactly regarding that slide. For Travis CI, you wrote down good for small open source projects up to 100 builds. Does that mean that after 100, what does it exactly mean after 100 builds? I have to pay for it or what?
Yeah.
So whenever, for instance, when I set up my Travis CI, that it builds the project or tries to build it whenever I commit something, and after 100 commits, I can't use it anymore, at least not for free.
Yes, exactly. That's kind of problematic with Travis CI.
Oh wow, that's kind of...
That's unfortunate. I didn't know that. Like I was using Travis CI for a long time, only for open source, and we never paid anything. And clearly we went above 100 builds. So apparently this must be a new rule. Yeah.
Yeah, I guess so. No.
I didn't know that. Wow, that's a shame. Someone is asking, which is your personal favorite CI tool?
Good question. As for now, Circle CI definitely. I would like to look into Jenkins as well sometime. I think Jenkins is the most popular one and most established, and it offers quite a lot of plugins and support. So yeah, I'd say that. Any other questions?
I'm gonna use the quick moment of pause because I want to switch my Wi-Fi. I have troubles with my internet, so I will be off for a minute. But you can ask questions. I think the recording should also work without me. So I'm going to change my Wi-Fi setting for like my Wi-Fi which I'm connected to. Yuri, can you ask the crowd for questions?
You are now muted.
Yes, I'm still super surprised by the whole Travis CI thing. So to be honest, I'm Googling that right now. They have this credit system, which I'm not liking already, because then you don't really know how many credits you need to use the CI CD environment. Okay, but never mind. Are there any more questions? If not, it's, I guess, Jonas' turn.
Okay, could you grant me the presenter role?
Sure, give me a second. There's one more question. So the slide says Circle CI is server-based. Does that mean there's no official platform for it and I have to set up a server myself?
I've seen it, yes. You'd have to make use of your own server.
Okay. I think then, Jonas, you may continue.
Yep,
Thanks
I'm
again.
uploading the PDF right now. Okay, so before I officially start my talk, this talk requires prior knowledge of Docker containers. And so for everybody who does not know what a Docker container is, you can think of it as a lightweight virtual machine that's dedicated to a single application. And with it, you get packaged a recipe to create this application and to configure it. Okay, Robert, you're back.
Yes, apparently.
Okay, then I'll start my timer. And this is about Kubernetes, a production-grade container orchestration tool, which allows you to automatically deploy containers, scale, and manage them. This is a bit abstract, so we're gonna close in on this through a use case. So imagine we finished this university course. We developed a single-page application, added a backend or web server with Golang, and added a database with SQLite. We want to host our application, and we install it on a single server somewhere. So we install the packages, we clone the repos, and we configure the files. A little while down the road, we want to replace SQLite with Postgres. So at this point, you already have to decide whether to remove SQLite or just leave it there. But in any case, you need to install Postgres and configure it as well. Sometime later still, you want to add a second server because the load is increasing and you want to split between the database and the front-end web server stuff. So now you have to move some parts over to a second server, reconfigure, and add new packages. And you also have to already manage two servers. Sometime your application server just dies, and now you have to move to a new application server, move all the packages, reconfigure the new server appropriately, and it's already a bit messy. At this point, as a user of Docker, you kind of think, well, I could just package my applications in Docker, install Docker on all servers, and then I can quickly install and remove Docker containers wherever I want. This works great if you have a handful of servers, but if your system and your system architecture grows more complex, you end up feeling very annoyed because you have to suddenly install Docker everywhere and you have to SSH everything, and it gets messy. So this is where Kubernetes comes into place. With Kubernetes, you put up a Kubernetes cluster, which means you bundle all your nodes, your servers into one logical system. You install a Kubernetes services on all the nodes, and you install a master process which manages your nodes. Now your cluster is managed to Kubernetes, and you can automatically install applications. But what does that mean? Well, an application in Kubernetes is represented by a pod. A pod can consist of a single or multiple containers, configuration secrets, and volumes, which means dedicated storage that is not meant as a temporary scrap storage, but for longer use and reuse. Pods are configured through text files like JSON or YAML files. Here you can see a single pod spec for one container that is a Redis image, and it has a request of 100 megahertz CPU and 100 megabytes of memory. You also configure a port to listen on for the server, and this is the port 6379. What Kubernetes now does allow you is to just simply install the applications in the cluster, and Kubernetes will handle the dispatching of the applications to the nodes, the setup, and the removal if you want to remove a container application. What Kubernetes also allows you to do is bundle pods together in a service and create deployments. A service is just a configuration for a set of pods where you say, okay, I want to select these pods. They should be known as a single service. In this example, the name is my Redis service. And what you say here is set up a DNS name in my cluster called my Redis service. And whenever you connect to the service, it should redirect to one of the pods with the app name Redis. and it should do that through the ports as specified. A deployment, on the other hand, wraps a pod spec, so a specification of a pod, and it allows you to create multiple replicas. Deployments and services are also just configured through text files as a pods. So for example, we have a singular pod here in yellow up in the upper left corner. And now we can change the deployment script we configured for this pod to have 4 replicas, and Kubernetes will automatically scale up our deployment and install 4 pods on the various nodes wherever there's enough resources available. So with Kubernetes, you can create clusters, complex clusters, and don't have to care about installing and reinstalling packages and services. What Kubernetes also allows you to do is create logical configuration entities and secrets in which you can store passwords and make them available in the whole cluster, separate from the applications and separate from the storage. This concludes my quick, short talk on Kubernetes. I'm sure there are many questions open how to use this. I would refer to the Kubernetes documentation. It's really nice. There are interactive tutorials. And if you have any questions about this presentation, feel free to ask.
Excellent. Thank you very much, Jonas. That was an amazing lightning talk, and you're about 5 minutes and a couple of seconds. So that was right on time. Very nice. And I'm super excited to hear something about Kubernetes, which I'm also really excited about. Oh yeah, the virtual applause. Thank you very much. And yeah, there are your first questions in the chat. Can you see it?
So there's a question whether storage configuration is still difficult. I personally haven't touched this in a while, but in our company, we use Kubernetes and we have people using this. And we use, for example, Kafka, the message queue Kafka, and narrow spike in Kubernetes. So for sure, there are solutions available which allows you to host storage in Kubernetes. But due to the dynamic nature, especially for beginners, it's hard to add storage to pods. And if you want to really make sure not to lose data, I would still suggest to use prepackaged solutions or use database services. But theoretically, it's in a good state. So for a pod, you have to configure a persistent volume claim, which means this application wants some storage. And then somewhere in the cluster, you also say, okay, this disk is a persistent volume, and it makes this space available for Kubernetes to claim. And then Kubernetes can say, oh, I attach this storage to this pod. But for beginners, as I said, it's still very complicated.
Maybe I can add to that question, because I do have experience with Kubernetes and exactly that problem. We had, for example, a cloud. We had a couple of front-end pods, a couple of back-end pods, and then we had the database. And the database needs certain file access. And we were deploying to DigitalOcean. DigitalOcean offers a managed Kubernetes cluster, and DigitalOcean does not offer, for example, 2 pods accessing the same persistent volume at the same time, right? So you can have a volume which will survive if you kill the pod, for example, and then you create a new pod, and the new pod can claim the volume. But if you have 2, then you have a problem. And that's depending on the Kubernetes provider. So there are other Kubernetes providers out there which have the feature of multiple access, multi-read, multi-write-read access, I think. And that's now provider specific, okay? Does that make sense?
Kirill also had a question on using Docker CLI with Kubernetes. So Kubernetes itself is agnostic, well, not really agnostic, but independent, decoupled from the container tool you use. So usage of containers in Kubernetes is pretty much transparent. So you don't get access directly to the Docker CLI. You could log into the service and meddle around with it, but it's not suggested, and you usually only work the Kubernetes configuration. Atana said, yep.
Maybe we can also add to that. So if the point of accessing Docker CLI in a Kubernetes environment is to, for example, inspect logs, right? Because we want to connect to a Docker container. That's the purpose of it. Then kubectl has already built-in commands for that. Does it answer the question maybe even further? Oh, Docker Swarm will be deprecated in a few years. Is that true?
I guess so, because Kubernetes is the better alternative. Actually, Atanas had a different question on single point of failure nature of the master process. So the Kubernetes master itself can be distributed among the nodes. So if one of the nodes hosting the master part of the master process dies, Kubernetes can replace this. So unless all of your nodes die at once, usually the master process can survive that.
I also got a question. I'm wondering. So before you basically used different tools to just simply host your application, which you are developing on directly on your PC. So Vue or Go or your SQLite, what you just opened. With Docker, people moved towards hosting that on Docker itself. So then you also have to streamline your development experience, and it's always the same for all the developers. But now, when you start to deploy your production environment, and also the thing is that you can also that you also have the same environment for your development as for your production, because you containerized it. But now with Kubernetes, you cannot really host a complete Kubernetes cluster on your local machine to make sure the development is the same, right? The development environment and the production environment.
Okay, so there are, I guess, multiple questions in it. So there is actually a solution to host a Kubernetes cluster on your computer or on your PC. One popular solution is Minikube, which uses VirtualBox VMs to spin up and mimic different nodes. And then you can actually build up your own Kubernetes cluster locally. The question of whether development is still the same is a good one, because especially in our company, that's still a question that has not been fully closed, because it's difficult to have all the services that you usually have in a Kubernetes cluster also locally. So what we usually do is we concentrate on building the Docker images, the Docker applications, but we don't mimic the whole Kubernetes cluster. But yeah, there's potentially a divide between what you run locally and what you will run in the cluster.
And then it's also quite resource intensive.
Yeah, maybe you can also add to that. I would also give you the suggestion, use Minikube for local development. But again, different Kubernetes providers offer different features. Like in theory, you're right. You can mimic or you can simulate the entire cloud on your local machine, in theory, but there are still differences, like provider-specific differences. As I said, I gave the example with the multi-read write access. Minikube, for example, allows this. Minikube implements many read-write access. So I was writing my my Kubernetes configuration for Minikube, thinking, well, if it works in Minikube, it will surely work in DigitalOcean. I deployed it to DigitalOcean, and then boom, it didn't work, because this didn't appear to me. So in theory, yes, you have an interface, and in practice, sometimes no, because still there are provider like proprietary differences. And Kubernetes is more like a stack where you have different, for example, there are also features which are up to the provider. Or what should happen if you, for example, spin up a load balancer? I think that's by specification already up to the provider, if I remember correctly. So yeah, does it answer the question, this example?
Yeah, I knew about Minikube. I was hoping there's a a more streamlined, slimmer solution. But I guess not.
What you can also do as an alternative, maybe, I was having experience with a tool called Traffic, which is, in my opinion, an alternative to hosting your, for example, Kubernetes cluster yourself. This is like a software which you can install on a VPS server, and you can run Docker in production, which is very, very, like it's smaller and maybe easier for smaller applications like ours. If you want to deploy the application that you're building with your homework exercise, you can use that one. And there are different ways of deploying containerized applications. First of all, different containers tools like Docker and others, and also alternatives to Kubernetes. But Kubernetes is very feature-rich and very, it's currently, I would also say, if you really want to scale, then it's the way to go. And for example, if you want to have managed Kubernetes, that costs you one cluster, the smallest cluster on DigitalOcean, for example, $30 a month, plus all the services that you need on top of that. Define small, one cluster, and you need $10 for the load balancer if you want to make it accessible from the outside, so $40. I think in this, you just have one cluster with three physical machines, and each machine has, I don't know, 2 GB of RAM, a couple of gigabytes storage. Oh well, I don't know, because Kubernetes doesn't have storage. Anyways, it's about $40 a month. Starting from that. It's irrelevant of the number of deployed pods. Yes, because you can run multiple pods on a physical machine. However, if your pod need a lot of memory, which happened to us, and you have multiple pods on the same physical machine, then your memory will run out, and then you have to tell DigitalOcean, I need more hardware, please. But yes, you can deploy as many pods as you want. What I really like about Kubernetes is it's an interface, right? Kubernetes effectively solves the vendor lock-in. You can build for Kubernetes and deploy that to any Kubernetes provider out there. Well, as long as it's not depending on some proprietary features, as I told you earlier. So that's my opinion, the killer feature of Kubernetes. All right, more questions otherwise? No? Cool. Thank you so much. That was amazing. Thank you, Jonas. Thank you, Ilona.
Thank you.
I'm going to switch to the other slide, which hopefully is all there. It is. There we go. GraphQL. The new homework is uploaded. So if you go to our homework repository, exercises /3, then you will see the new homework exercise. Oh, well, let's have a look. Why not? And it's about GraphQL. So my computer becomes slow again for some reasons. Hope you can hear me fine. So here's our new homework, and I deliberately added more instructions because I think a couple of groups had difficulties with the setup in homework 2. So there's a lot of instructions here and a lot of hints which might help you. However, the actual objectives are still there. And it's about GraphQL, and you basically you're supposed to implement a server, which is having this schema here. And provide resolvers for that. And test it, of course. So there is a framework called apolloserver testing. This one here, you can check that out. There's how you can run tests against your Apollo server, which is an implementation for Node.js for GraphQL server side. Have a look at this, and is there anything more to say about it? Jury? Maybe that connecting your web app with the Apollo server is optional. Maybe you should say that.
You are now
Yuri,
unmuted.
any more input from your side? Yeah, right. The code review. To help us a little bit, you could, or you should,
You are
you
now
must.
muted.
We will update this homework. We will add one bullet point here. Please link the code review that you've given in your pull request description. So if you create a pull request, then you can, interesting, there's still this one here. Did I not match that? Sorry, I didn't see that. This is someone who's not a member of your team, please. Is that just a language
You are now
correction?
unmuted.
Or does it change the content? Anyways, yeah, sure. Cool. Why not? We're going to update the homework anyways. Let's do that first. But yeah, you can, of course, edit the description of your pull request. Oh, cool. I can even edit the description of his pull request. And then you can link to the to any pull request review that you've given, right? And you can link to a pull request review by clicking on this here. So there's always your username and then approved or suggested changes on this pull request and then a date. And then you can click on that and that will change the URL. And you have now this anchor pull request review and then some strange ID. And you can use link that into your pull request and there you have your review. Does that make sense? All good? Time for a poll, I think. All good so far? That gives me some time to look into the public chat. Please mute yourself. All right, looks good, looks very good. Okay, let's start with the actual topic, GraphQL. So, GraphQL is a data query and manipulation language for APIs. So this diagram, you already know that. We have been doing things over here and there. And now we're like slowly going down the technology stack and have a look into the backend, for example. And we're especially like covering this, this area here. So if you think of GraphQL, that connects your front end with your backend. Think of your front end as the part of the application that lives in the browser, or if it's also server-side rendered, it can also live on the server, but it's basically the application that's user-facing. And this application is somehow connected to, it doesn't have to, but in our case it is, somehow connected to a backend which runs on the server. And this application, for example, it deals with authentication authorization, is connected to the database, and is able to handle requests that are hitting the backend over the internet, right? So the internet is here, okay? This application, the backend, if it's wrapping a database, that one is lives on the server. So internet is here, and GraphQL is like the query language and for the API, right? It does not have anything to do with a so-called graph database. Last winter semester, I was introducing graph databases, and which one very popular misconception is that people confuse GraphQL with graph database, and it has nothing to do. The difference between GraphQL and graph database is the same as between Java and JavaScript, right? So they don't have anything in common. So GraphQL is really here, whereas graph database would be there, right? And GraphQL really doesn't have anything to do with whatever is behind the backend. All right, hope that helps. What's the motivation for GraphQL? I like to introduce GraphQL by comparing it to REST. You probably know REST. It's called representational state transfer or something. It's the current most used specification of APIs. So usually it's a request to an endpoint, and REST uses HTTP verbs, get, post, patch, and delete. And you have the basic CRUD functionalities: create, remove, update, create, read, update, delete, implemented with those HTTP verbs, and you have an endpoint. And if you, for example, have an application like this, you have a social media app and you see some posts, then what happens with REST is that you make a lot of calls to the REST endpoint. So you have a number of posts, and each post has a number of likes. Each post has also an author, which you can see here. The author might have other data, which could, for example, be his location, the number of his posts, so aggregated data. The author is author of a number of posts, and you can see the total count here. Same, you have a number of comments by this author, because this author also commented on other posts. Of course, you have comments on each post, right? On REST, this can lead to many calls, because what happens is you have those endpoints, which you can see on the left. And let's say you go to the website, and your client is going to crawl the list of posts, right? You get the list of posts, and then you want to get data about post number 42, and then you get something like this back. Right? This is the data. Of course, maybe there's more data in it, but the data that's for the post. But since you also want that the client is currently seeing a page with a post and a number of comments, and each comment has the text, then you also want to have the data of all comments for that post. So what you're going to do, once you have the post, then you make another HTTP call to get all the comments for post number 42, for example. And in between, you have to wait, right? And you need to also render the user who wrote the comment or the post as well. So what you're going to do is you are going to crawl or get the data for the user with the ID number 1, right? So make another call, which gives you this data, and can show the name of the author, and same thing for this user here. And as you can see, this is rather slow. It's expensive, and it's the worst of all, it's over the wire. So that means the requests are all sent over the internet. What you could do if you have an API like this is you just add more data to those endpoints. So when you, for example, access the post endpoint, then you not only get the data for the post, but maybe all the data for comments as well. But if you think of that is here, you don't actually see the comment here, right? So if you would just always send all the data for the post when someone is retrieving the list of posts, then you're actually sending more than you need to. And this can be some data, right? I mean, for each post, you get a number of comments with all the entire data structure, which might be a lot. So you basically, you add more data. The data that's being sent to you over the internet is much more than you actually need, which is bad. Otherwise, if you don't do that, then you have the problem of sending a number of requests, which I think is even worse, because you have to wait for so long. You're sending a lot of requests here, and each of those requests can also maybe fail, right? And then you have a problem, and more requests means more errors, more requests, and especially waiting between those requests. So you get the list of posts first, and then you know the number of IDs, and then you have to make for each ID another call. It's like N+1 problem, and that's bad, really, really, really bad. And I think we call it overfetching or underfetching, and having a lot of requests. Does it make sense so far? People are talking about the homework. So that's actually a nice question in the chat. First, let's publish the polling result. Someone is asking if you're supposed to create a new branch for the new homework. For me, it absolutely doesn't. I don't care what branches you create or how you name your branches. The point is that when I give a review, then I want to see in files changed all relevant changes. So I can use, for example, the suggest button. There have been groups which apparently merged some changes for homework 2, then created another pull request which only included the changes for Storybook. And then I am not able to see the changes on GitHub and also not give a review on the changes on GitHub. So make sure that all the relevant changes and only the relevant changes for exercise XY is in your Files Change tab. So when you create a pull request, always make sure, go to the Files Change tab, have a look if all the required changes are there. This is also something that you can train if you give other people a review and other groups are doing that and you cannot see all the changes, then you probably get annoyed, and that's good because it gives you an idea what's important. If you create a pull request, you want to show code someone, so make sure that the changes are actually in the files changed. If you already merge changes into your master, so if master is the target branch you want to merge changes into, so the master has some commits which you actually wanted to be included in your PR, then you have to either reset the master somehow, or you can also create a new branch and point your pull request into that branch, and this branch doesn't have the changes yet. It's up to you. There are different options for that, but make sure in your Files Change tab, there's all the changes relevant for the homework. Hope that answers the question. So people said, I'm okay. So how does GraphQL solve the problem with these problems that REST had? GraphQL is different. GraphQL, the whole idea is that you send one request, and in that request, your client, the browser, tells the server what data the client needs and just that data. So you can, what you see here is basically the same thing. This here translated into GraphQL. So your query could, for example, look like this. You have a post, which when you're saying, give me please post number with the ID P9, and I want the ID, the title, and all comments of that post. And for each comment, I want the content of the comment. I want to see the author. The author himself is a user, and the user, each user has a name, right? So you're like querying your virtual database schema if you want. Yeah, the point is that the client can tell the server, I want nested data. And you can do everything in one request. That's the point here. Like you send one complex query to your backend. The backend is able to retrieve all the data for the client and then sends one response containing all the required data back to the client, right? Which solves beautifully this problem, which on which REST is suffering, that you either have a lot of requests or you have a large payload. And it's very flexible because depending on in which situation the client currently is, maybe I'm looking at something like a news feed. So I just want to have a list of posts, not so much data, or I'm clicking on a post, then I want to see all the data for the post. Depending on my situation, I can send a different query and get the desired data back. Also, GraphQL doesn't have multiple endpoints, so you have many endpoints here, and GraphQL just have one endpoint. And instead of relying on the protocol, so you send HTTP verbs depending on what you want to do. So you send a get in case you want to read, you send post if you want to create data, always send request. And in the post request body, you encode what you want to do. So this one here is a query. And in GraphQL, there are also mutations. Mutations change data. Queries only read from the endpoint, and mutations can change the data. That could be like a deletion of data or creating of data, updating data, and so on. No questions so far, so I'm just going to proceed. And here you can see a sequence diagram, what's actually happening. So you have REST, and yeah, that's basically similar what I said. You send a request to the server, then you have to wait, then the client decides what to do next, sending another request to get more data, depending on what's required, and so on. This can take a while, and this is happening over the internet, whereas the client sends one request to the server, and maybe the server has also to make multiple requests. Maybe you need to do multiple requests to a database. Maybe you need multiple requests to another REST endpoint. That can be. So this time here on the server might be longer than what the server would need for one request. But the point is, it's not going over the wire. This is happening on the server itself, right? So in total, if you think of the entire process here, it's much, much more quicker. It's much faster in execution than a number of requests which kind of depend on each other. Someone is writing. Feel free to ask questions in the chat,
You are now
or
unmuted.
just unmute yourself and ask them directly. Mhm. Yes, that's a nice remark. So this one refers to the HTTP verb called post. So the HTTP is protocol, and you can send, I think it's called HTTP verbs, and post is one of them. And in there, we are talking about an entity called post, a posting. And that's actually right. Maybe I should change the slides and use something else. Maybe article or something, or I don't know, or posting. So you can easily see, like, this one does not have anything to do with that one. That's what you want to say, right? Yeah. And the response also have always a data, which is the entire data, which is coming back from the server, as well as some an errors key, which can have a number of errors if any errors are present. And here is your data structure, and this data structure resembles what you queried for, right? So ID and title is this one is returning one item. Like in here, the query would return exactly one post. That's why you don't have an array here, just an object. And this one here is returning an array of things. And that's why you have the array here. You can see the square brackets, right? So this one is a comment, this one is a comment. And author, you always have one author for one comment. So you have an author key which has one object always. Does it make sense? Do you have examples when we actually don't want to use GraphQL in favor of REST? That's a great question. That's an amazing question. So the question is more or less, what are the benefits of GraphQL? Well, I told you the benefits of GraphQL over REST already, but is there also a benefit of REST that GraphQL doesn't have? And I'm always having troubles to motivate or to suggest REST over GraphQL, because I think there are some drawbacks. If you type in pros and cons REST GraphQL, let's do that. I'm going to screen share for a second. So if you go to the internet and you just type in GraphQL, REST, pros, cons, comparison, then you see a number of resources, and you see, I already Googled for that as well. And to me, I don't really see that there are so many problems with REST, which I would say is really a reason why not to use GraphQL. I think you can basically use GraphQL if you have the choice. There are situations which I can think of where GraphQL doesn't really have where GraphQL cannot really shine, right? So the benefits of GraphQL are not that imminent. But if you have something like an app, then usually it happens really quickly that you have this problem with REST. and then GraphQL is way better. There's some reasons why people prefer not to use GraphQL. For example, if you have a client and let's say you have an HTML form, the browser, the default behavior of the browser is to send a post request. And if you want to tell the browser, please do something else, then you have to divert from the default behavior, right? So you have to have more effort, for example, on the client side. Another problem is that if you have many REST calls, some of those REST calls can be cached by HTTP caching. And obviously, if you have just one request, then you cannot use can leverage that caching mechanism. But I would say there are other caching mechanisms built in GraphQL which take that role, and you wouldn't use you would use caching mechanisms in the application layer. That's the point here. Another drawback might be is GraphQL and denial of service. So since GraphQL is doing more, handling a GraphQL request is doing a lot of work on the server, it's easier to send, bring the server under a lot of pressure. I mean, you can do the same thing with REST. You just send a lot of requests, and then you can also do a denial of service. However, in GraphQL, it's particularly easy sometimes, and there are also solutions for that. You just, for example, limit the number of nested resources that you can query for. If all your, oh no, my slides are gone. If for every nested resource you make another database call, for example, then you don't want to have nested resources of 20 or 30 levels deep, because then your server is doing a lot of work. So you have just to sanitize those GraphQL queries. And there's, of course, there are libraries for that. So I would say there are some disadvantages sometimes, but really most of them can be fixed pretty easily. And my experience, for example, from this year, I'm working currently on a project, and I was arguing with my coworker whether to use or not use GraphQL. And my coworker said, well, maybe start lean and just don't use it for now and wait until we really need it, because our application seems so simple. And what happened, of course, we never really were able to refactor it, because this one, you're changing, when you're going from REST to GraphQL, you're changing an interface, all right? And changing an interface is always a lot of work, because you have to touch the front-end code and the back-end code. So if you have an application in you have a full-stack application and you start with REST, later on refactoring it to GraphQL, is some work. GraphQL makes it kind of easy to wrap, for example, an existing REST endpoint. So if you're working with legacy code, you can have a GraphQL wrapper, which is sending REST API calls. And then you can, step by step, refactor your client to use GraphQL instead of REST. That's possible. But in our case, we never did that because we were lazy. And now we're really suffering under that decision. So that I'm totally sure that was a bad decision. I should have been more insisting on using GraphQL. Hopefully that answers the question. I'm gonna have a look into the chat again. Yes, you can combine those two, of course. Okay, let's continue on with the slides for now. So what's really important also for the exam is to understand how a query is kind of handled on the server. So if you send a query like this, and you have a schema like this, there are two magic types. So GraphQL is a statically typed language. So you have a schema somewhere, and in the schema you define what are your custom data types. And there are two magic types. One is called query, and one is called mutation. And these magic top-level types are defining what's your root query that you can send to the server. So here we have a root query called post. So this post here refers to that query. And you would write query, or you can also omit this word, and it's the default would be a query. Or if it's a mutation, you would write mutation here, and then square brackets. And then the name of your query that you want to send to the server. And this here, the post, is has a response type, a return type of a number of things that are of type post. And what is post? So this post here refers to that type. So now the server knows whatever comes back from the server here, I can request, if I want to, I can request title, comment, comments, shouted by, whatever. In this case, I'm requesting on the client, I'm requesting title, contents, and comments. All right. Now, this one is a so-called scalar type string. It's just basically a piece of text that's being sent from the server. However, this one here is another type, which I declared over here. So a comment has a content and author. So that means I can here in comments then request those fields that are listed here, right? So I can ask for the content of the comment, and I can ask for the author. And the same again. Author is of type user, and user is defined here. So for each author, I can ask for the name. In this case, author is only singular, so I have one author for comment. So yeah, this will return just one object here. And that way, the client can also understand, the client knows already what's the expected response from the server, right? So you have a JSON, and there's one object which has the key data, then another object which has the key post, then an array, so square brackets, then objects which have these keys here, and for each object, the key comments will have another array, and so on, right? And we'll have a look. Yeah.
So what does the exclamation mark do? Does it say it's nullable, or?
That's a great question. So exclamation marks means it's not nullable. So
okay.
Yeah. So every post must have a title. If the server ever tries to send back a post which doesn't have a title or a title null, then the entire object will be nulled, and there will be an error, right? So this means post must have a title. All right, and let's have a look how this request is then handled. What's really important is to understand the method signature of a so-called resolver. So a resolver is responsible to handle a part of the query or the mutation. In this case, we are looking into the top-level resolver called post, which is a key in these objects here. So this is JavaScript. The resolver is somewhere in my code, and I'm exporting an object, and the object has the same. It looks very similar to the query I'm sending here. All right, so it's all starting with query. So in query, I'm listing all the resolvers. So there can be many more here. I just omitted them, so you can see only one, the post resolver. And this resolver will be called if the client is going to request post. Okay, and it's really important to understand the method signature of a resolver, which you can see here. So this is like a key value pair, and the value is a function. The function, in this case, an async function, and the function always has 4 arguments. And here you can see the arrow, so that's not an object, it's a part of the function. I think that's the matching square curly brace, right? So this here, until there, is a function. And this function will be called by our GraphQL implementation. In this case, it's called apolloserver, whenever the client is requesting post. All right, so yeah. Parent is the first argument of the resolver and always refers to the parent of the hierarchy, the execution hierarchy or something. I'm having troubles with vocabulary now. But since we are in the top level resolver, there is no resolver which is in the hierarchy further up. So this will always be undefined, right? That's why I'm writing it here. So this is the result. If it's a top-level resolver, parent is always undefined. And then whatever we return in this function will be passed down to the next resolver, right? So here we're returning an array because, as you remember, this is supposed to be an array. That's why we are returning an array here of things, in this case, objects. And we already have some data. So here we're just statically writing the actual data that's being returned in the resolver itself. So we have ID, title, and content. That's just a piece of text. And you can see we don't even request ID here, yet we pass it over to the next resolver, right? So client didn't request ID, but it's there. Now, if we go to the next resolver, so apolloserver will call any resolver if it exists for each, how do you call it, Yuri? What's the correct term for these things, like the levels of the hierarchy levels in a GraphQL query? Is there a particular term for that?
You are now muted.
I hope you get what I'm talking about. Things here. So when this resolver is finished, it will return an array of things which are of type post. And for each post, I can then call another resolver, or well, each key, or each argument, well, what's called? Argument, param.
You are now unmuted.
Property. Property is good. For each property of the post, I can call another resolver. In this case, I implemented a resolver for the comments. So if you see here, the comments are not there, right? So they would be null. If I would return the post as they are right now, then comments would be null, which is not even allowed. So the server will crash if I would null the comments array. However, I implemented a comments resolver for the type posts. So compare that one here, right? So this is like a so-called top-level query, right? Which refers to that. But now for each post, I can call all resolvers for each of the properties which have been requested by the client. Only those resolvers which are requested by the clients are actually being called, right? So here I'm requesting comments, so comments resolver will be called. And then suddenly parent is not undefined anymore. Parent is the object. So this resolver will be called for each object I'm returning here in the post resolver. So I'm returning an array with just one object. So the comments resolver will also be called once. And I receive from the post resolver, I receive the parent object, which is an object of type post, right? So here, ID, title, content. You can see that here, ID, title, and content is abbreviated. And then, since I'm returning a number of comments here, I'm returning an array of comments. You can see brackets, and this matches, well, should match, doesn't have to, the type comment, right? So comment also has an ID and it has a text attribute called content. And to make it even more fancy, also we have a resolver for type comment for the author, right? So content is the string that I passed in. There's no extra resolver for content. So the server will just respond with the text content here. But for author, there's another resolver here. And for each comment which will be returned by the server, this resolver will be called if the client requested author. Now, the parent is not the post, but the comment, right? Always think of that if the parent refers to what's here, right? So this is always of data type what's here. And that's why query, well, just because it's a top-level query it's always undefined because we have to start somewhere. Like this is like the root of all, and then for each property which has a corresponding resolver, we're calling that resolver. All right. Yeah, that is like the example. And it's really important that you have a look into how this method signature of a resolver is built up. And so far, does that make sense? I'm really interested to see your opinion on that if you're confused now. First, people are getting really confused. So I'm going to look into the public chat. This looks very much like gRPC. Unfortunately, I have no idea what gRPC is. Layer. Yeah, maybe you can call it properly a layer. All right. All right, 6 people are being confused by that example. Maybe it helps if I share my screen and we have an actual example. I like to ask in the exam, for example, to make sure you all understand how the method signature works. There's actually example code in the exam, and you have to tell, I'm logging out, for example, parent, and then you have to tell what is parent. So here we have some example code of an Apollo server. Here's our schema, here are our resolvers, and then I'm logging out sometimes the parent. And your task in this exercise in the exam, for example, is write down in which order the resolvers are being called and what's the value of parent in this case, or parent ID. All right. And the nice part about this exam is that the entire code is checked in the repository here. So what I could do is I just go to homework and go to archive, exam, code, GraphQL, and say yarn run start and get my Apollo server listening on localhost 4000. And this one here is the so-called GraphQL playground, which is, I think it's an application which comes with Apollo server, which is awesome for local development. And you have a couple of tabs here, and here you can write your GraphQL query, and when you click the play button, your result will end up here. Yeah, all those tabs are important. What's also nice is that you have the schema. You have the schema here, so that's the schema by the server. And you can also like explore the schema interactively. So you have 2 top-level queries called student and all students, and then you have the return type of each of those, which you can see here, and then you can see, okay, and yeah, browse the schema basically, which is amazing. It's also one of the big advantages of GraphQL that you get this the API documentation for free. And with GraphQL Playground, I can also interactively write queries, right? So I can, for example, say query, and then hit Control and space and get autocomplete because the client already knows the schema. So the client can tell me what are my options. In this case, we have exactly 2 top-level queries, so that's why it's populating the drop-down menu like this. So student, now I'm getting an error because student will return an array of type student. So what I have to do is to add curly braces again, maybe make a new line here. And then I have to ask for, because it's an array of things, I have to ask for properties. For example, I could ask for ID. And that already is a valid query. Null, because I'm not asking for an ID here, which is actually a nice error. So maybe ask for all students. Yeah, true. Student only returns 1 object. All students returns an array. Okay. So ID, and then hit the play button, and there we go. Then we have our 2 students with the ID. If I request more, then I have, for example, first name, and then you can see first name is being added here, which is amazing. What else I have? I, for example, have last name or full name. Nice, cool. And I can see the result, for example, here. So that's what you can write in your exam, log out what's parent. So let's have a look into the actual code. So all I have to do basically is just to install apolloserver. And we're not using, by the way, we're not using those import statements. This is, I don't know, I think the name is CommonJS imports. I don't know. But this is just a call which returns an object, and then you have, then you can use the library like that. So we need apolloserver and GQL. GQL is only used here. It's on my machine. It's also, my editor knows syntax highlighting. So when I say GQL, then Vim knows this is a schema. But actually, it's just a piece of text which is being being put into the server later on. So here's our instance of apolloserver, and I put the type defs here. So that's like the schema definition. And then I have to implement each of those types somehow. Something should happen when I call the server, right? These are my resolvers. And a resolver is really just a plain object. Maybe we should start lean. Let's remove some code here, like this, and this, and maybe even this, and just return, for example, an empty array. All right, so we always have query, or if we have mutation, we would have that. But we don't have mutations defined for the moment, only a top-level query. And this is this here, the all students top-level query, which corresponds to that. We can also return student. Fine. And then we have this type student, which is corresponding with this type over here. And maybe also remove first name for now. And right now, we're just returning an empty array. So when I start the server again and run the query, I get kind of query full name because it's not there anymore. I get an empty array, right? And I can also log out what's console, what's parent, sorry. Yuri, can you ask me questions if people write it in the chat because I can't see them right now?
You are now unmuted.
Oh yeah, GraphQL, Node.js. So apolloserver is just the most popular one. But there's one implemented by Facebook. So GraphQL was originally implemented or specified by Facebook. And I think Facebook is still like shipping their own implementation, like for JavaScript. Alternative to apolloserver. I forgot the name of it. Or don't use Apollo. Okay, interesting. Muted. Yeah, it's all right. Okay, they're using Express GraphQL, but is Express GraphQL not just using also Apollo internally? Anyways, but there's, yeah, there are implementations, of course, for other programming languages. GraphQL implementation. So first of all, for other programming languages like Python, Go, there are different implementations server-side. They have another name, of course. And for Node.js on the server, I think there's one by Facebook. Can someone help me? It's apparently not often used, so Google doesn't know what I want. Okay, anyways, I know there's one by Facebook. I just don't know the name. Maybe some of you can tell me. I'm going to have a look into the public chat. 7 new messages. Oh, okay, that question was the last message. So yeah, I know there's one, but cannot find it right now. Does it answer the question? Yuri, is it answering the question?
Yes.
So yeah, so every time I hit play, there's another call made to the apolloserver here, right? And you can see parent undefined. What's cool, for example, I can write, well, first of all, I can, of course, return some object here. So just return something that has an ID. one. And by the way, this can be anything. Just doesn't have the type. This is a scalar type ID, and it's supposed to be of text, and it just has to be unique for every object of that type. So you can write anything. Contract again is just needs to be unique, because that's how your client will cache the object. So if you get on the client side, if the browser receives a new object and has an existing object with that ID already, it can internally update the cache. It can update the object in the cache with the ID so-and-so, and then update the whatever the stored there, which is amazing, right? So that's also something that you don't get with REST, because you don't have this contract of the schema. It's not really easy to implement efficient caching mechanisms there, but with GraphQL that's possible. So first name, Alice, and last name, I don't know, Alice A. Okay, fair enough. By the way, I think Apollo by default doesn't have server hot reload, so that's why I'm starting the Node.js server all the time. If I just return an object, I see it here. It's always the same, because in the resolver itself, I returned that. But let's say I want anything else. Student has okay, I'm not really creative. I had full name already, which is a string. And I don't necessarily have to put it here. I mean, I can say full name and then return another string, Alice A, like this. And then I get the full name if I would request it. But that's not really cool. What's cool is that you can have a type resolver for every student. And then you say full name, and then this one responds to full name. I can actually override what's here with anything I want. So I can, for example, since this is a function, I can always return some full name. The resolver will take precedence over whatever's in this object. There you go, some full name. And now I can make use of this parent thing. So parent is each object which is returned in the all students resolver. All right. So what I can actually do is I could say parent first name plus parent last name. Yeah, I need to restart the server every time. I didn't hit save. Because I don't see any difference. Okay, Bob builder. Now you should see it. There we go. And there's a missing space. We can fix that easily by, for example, writing something like this. There's a string interpolation in JavaScript. There we go, right? And I mean, I don't necessarily have to put that data here. I can also just put it somewhere, like here. I can make a students array, which is like now resembling my database. I can just put that there. Oh, maybe like this. Huh? Yeah. So I have my pseudo database, and I can reference that, for example, from here, students. That's it. Cool. Now, that's nice. And I can, yeah, this is how you put the data somewhere we want. What I can also use is the so-called args. Args is a way of adding arguments to each of those properties here. So if I have full name, I can specify a parameter or an argument to that, well, function property. and, for example, say something like reverse Boolean, and then I could make this more complex. So this is always what's up here is being put as args in the respective resolver, right? So I can see the change if I start Apollo. This is still a valid query, but now I can actually optionally add another argument here, which is always of type Boolean. So I cannot just write just anything here. Then I will have an error, which you can already see here. And the Apollo server will return with an error. Boolean cannot represent a non-Boolean value. So that's also nice because everything is statically typed. This is like type safety for your backend, right? Some certain values are not able to be sent to the backend. And GraphQL, or in this case, Apollo server, is taking care of that whatever is sent to the backend and handled and maybe sent to the database is always of some particular database, some particular data type, which is super amazing. So I'm gonna say true, and nothing happens. But this shows you how to use arguments. If I will make this required, what's going on? If I would make this required, restart the server. Then, if I would return, like remove that, and I should actually see, yeah, field full name argument of type is required, but it was not provided, which makes sense, right? So I'm going to add this again. Now it's valid. Nothing happens because we're not doing anything with the argument yet. But we can do that so by doing something with it here. So in the respective resolver, in this case full name, I can have arguments wherever I want. I can also put arguments in the top level query. However, this time I put it in the type resolver here. And then the arguments are available in the respective resolver. So here. All right. Put the name, you can actually see it's happening. Args. Cool. So now I have another console log over here, which is outputting my parent, which is always undefined if it's a top level resolver. And then I have the type level resolver, which is giving me the parent, which is the student. And I have this argument, right? So this is what the student resolver, all students resolver returned and passed down to the full name resolver, right? So here, this is full name resolver, and this was the other one. Maybe we should return that first. Let's return that console log statement. You can see. All right, parent args. There you go, 2 log statements, nice. And here are my args. To change that, false. And again, 2 nice log statements, and reverse is false. So that means I can use that and make something with it. For example, I could, if args reverse, then it's true, then it return that thing, but reversed. There we go. Nice, cool. That's amazing. So now you have an idea what's the parent and what's args. You can check the GraphQL resolver method signature somewhere here in the internet. Resolvers. They're calling it object. Oh, it's about time. It's 1:30. Okay, so to wrap up, the parent, which I call parent, they call, depending on like whatever. This one is a top level query apparently, so this will be undefined anyways. But here they're referring to the author, which is also nice. So you don't have to always ask, call it parent. Maybe why not call it student? Huh? Makes more sense. Oh, students. Well, but you get the point. But you can see the resolve function signature here. This is very important. And when you understand that, you understood a lot how to implement your own implementation for a GraphQL server. And for now, the only thing you have to understand is what's the first argument, what's the second argument, and the other two, sorry, we'll call it later. All right, so we're at the end of the lecture. I was talking for a long time, and yeah, now it's time for questions. Only 3 chat messages so far. Apollo is quite popular. Awesome GraphQL. Yeah, cool. Maybe add this to the shared notes. Questions, friends? It's the end of the lecture. I don't hear anything. All confused? I'm always getting slightly nervous when I'm hearing myself talking for too long. Not getting any feedback. Are you still alive?
You are now unmuted.
One person is typing. Yeah. It's not possible that no one has questions. That's super unusual and suspicious.
Also mal für mich kann ich jetzt sagen, ich werde noch super viele Fragen haben, aber solange ich das noch nicht selber mache, habe ich sie nicht.
Ja, kein Problem.
Nein, ich wollte nur Feedback geben, weil du sagst, du wirst nervös. Also ich werde noch ganz viele Fragen haben, keine Sorge.
Okay. Ja, eine bisschen bessere Learner Experience, ne? Es gibt ja analog zur User Experience, gibt es ja auch die Developer Experience und jetzt in unserem Kurs halt Learner Experience, also dass man halt eben das Gefühl hat, wow, ich kann hier die Aufgabe machen und ich habe echt viel gelernt danach. So, und einige haben sich ja irgendwie mit der Konfiguration oder dem Setup irgendwie schwer getan. Da dachte ich mir, okay, vielleicht beim nächsten Mal ein bisschen ausführlicher, ein bisschen mehr in die richtige Richtung schubsen. Viele von den Sachen sind immer noch optional, also eigentlich, ne? Aber ich weiß nicht, vielleicht hilft es euch. Ich habe halt eben selber eine Referenzlösung auch geschrieben und es sind mir auch so ein paar Sachen aufgefallen. Was mich zum Beispiel total verwirrt hat, ist, dass bei mir auf meinem Server, also ich hatte teilweise, hat sich der Server gar nicht gestoppt, wenn ich auf Ctrl-C gedrückt habe. Dann lief noch ein Prozess, das fand ich sehr irritierend und sehr verstörend. Oder halt, was ein bisschen nerven kann, ist, wenn ihr halt immer den Server neu starten müsst, so wie ich jetzt gerade. Könnt ihr das nutzen. Genau. Ja, bei den Random IDs übrigens habe ich da auch, glaube ich, teilweise in der Aufgabe 2 Sachen vorgeschlagen, die dazu geführt hätten, Duplikate Keys zu haben. Deswegen nimmt es einfach Random IDs. Ja, dann habt ihr das Problem nicht mehr. Auf Node.js könnt ihr mit der eingebauten Library auch Random Strings erzeugen. Das gibt es einfach unter Node.js ab einer gewissen Version. Da braucht ihr nichts zu installieren und ja, hoffentlich, genau. Hier vielleicht sogar noch ein Testcase. Ich war mal so frei, tatsächlich einen Testcase, wie ich ihn jetzt geschrieben habe, in die Hausaufgabenstellung reinzunehmen, weil da einfach ganz viele Sachen drin sind, die euch helfen werden, gleich von Anfang an sehr saubere, sehr lesbare Tests zu schreiben. Genau, und das Target-Schema. Für jetzt ist es halt vorgegeben. Ich denke mal, bei der nächsten Hausaufgabe dürfte da ein bisschen freier sein. eigentlich ist auch das Schreiben des Schemas ja interessant. Ne? Ich habe das jetzt festgelegt, aber das ist eigentlich auch ganz spannend, dass man das mal lernt. Okay, wie muss eigentlich mein Schema aussehen, damit ich irgendwie ein Schema habe, was für meinen Use Case wirklich passend ist. Und vielleicht machen wir das in der nächsten Hausaufgabe so, dass wir da nur sagen, was es für Features gibt und ihr könnt euch dann überlegen, was ihr dann noch hinzufügt. Und auch mal ein bisschen das Schema
You are now
erweitern.
unmuted.
Gut, dann einen letzten Blick in den Public Chat. Dann sehen wir uns in der Übung und dieses Mal, ihr wisst ja, fangt einfach schon mal an zu arbeiten. Die Gruppen, die jetzt einen zweiten Zeitslot sind, kriegen und dann halt eben ein bisschen später Besuch von uns. Aber vielleicht kriegen wir es auf die Reihe, auch bei allen Gruppen mal vorbeizuschauen. Ich hoffe, das ist besser für euch. Gut, dann drücke ich jetzt auf Aufnahme stoppen.